is CS797K. It's Wednesday, January 29th. Happy Kansas Day, everyone. No one cares. It's also my sister's birthday. I always wish my sister happy Kansas Day. It's the day Kansas was admitted to the state to the United States. I always wish my sister happy Kansas Day for her birthday. And she always wishes me some stupid random holiday for my birthday. So yeah, it's a family tradition there. Anyhow, today we're going to talk about hemming code and protecting your data with parity, ways to do it a little more efficiently than we did with our card trick. But before that, I want to ask, show you something about the Jupyter Lab Python debugger. Now, how many people do not have Jupyter Lab installed? Everybody has it installed? How many people have the debugger turned on? Yeah, no one's got the debugger turned on. Okay, so we're going to talk about the debugger very briefly, so you have it available. Why do you want to use a debugger? I mean, you can always just put print statements in your code, right? But debugging any moderately complex software is significantly easier if you can put breakpoints and just stop the program from running, or set watch points, and when a variable changes and goes out of bounds, if you're getting about out of bound error, maybe you can set a watch point, and see when that variable value changes and see why it's going out of bounds, right? Things like that. Print statements are great for simple code. If you created some code, if you've downloaded a recommendation off of ChatGPT and you plug it in and it doesn't do quite what you expected, right? You're never going to use ChatGPT, right? No, everybody's going to use ChatGPT. That's like, yeah. In the future, we'll all just be sitting there in our comfy chairs at home, and someone will ask us to do something. We'll push a button. ChatGPT will do it for us. Then we'll go back to sleep, right? Maybe. We'll see. But so print statements work for simple code, but you have to remember to take them back out. Breakpoints, watch points, so you can just turn on the debugger. Away you go. And if you don't have the debugger turned on, your code will just run, right? If you've got like event-driven programming, where you've got multiple things happening, multiple threads of execution happening, something's coming in, giving you a interrupt on your computer that's saying it's time to process this particular input. I worked at NetApp Corporation for many years. We sold disk storage. We had to get that data to the customers, right? When they sent the I/O request in, said, give me my data. We couldn't be out there saying, sorry, you have to wait 5 minutes, right? We had to get it to them within microseconds. Right, get it started going back. And so print statements slow things down. They change the timing. And so if you get something in and just in the wrong time, it's going to mess things up. Plus, using a debugger makes you cool if we have a sufficiently relaxed definition of cool. In other words, if you're a software developer and you're using a debugger, you're cooler than the people that don't use debuggers. Not that any software developer is considered cool unless you're Wozniak. This is what Jupyter Lab looks like on your computers right now. When you fire it up, of course, you've got the home screen, and then when you actually load a piece of code, and here's an untitled bit of code here, we'll just have a little bit of code. I've got all my interfaces here and everything. Save, copy, paste, so on and so forth. If I turn on the debugger, initially, all you see that's changed is there's this little picture of a bug. Right. Once you click on that debugger, then you have all sorts of user interface changes where you can show the panes of the thing. Let's go here. That's the bug icon. We click on that. We've turned on debugging. We can also go to View Debugger Panel in some versions of Python. You can set breakpoints in your code now. And so what it'll do is when I start to run the code, it'll get to that spot. And before it prints A raised to the power of B, B raised to the power of A, it will stop and say, here's what my variables are. These are the debugger panels over there. They show what the code looks like. Quick and dirty. So how do we enable the debugger? And that's the crux of this. It's just these two slides here. It's disabled by default. It's relatively easy to enable. As of September, these are the current instructions. If you find kernel.json, there's a file, JSON file that says kernel about how the Jupyter kernel works. There's a line that says debugger is false. So you just change that to true, and your debugger's turned on. The hard part is finding that file kernel.json. If you've installed Jupyter on your laptop, your Windows box, it should be in users/your user ID/app data/local anaconda blah, 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 down here in Python 3. If you are on a computer that's like the Podium computers where we had the media services install it and they installed it for every user, the file actually lives in C:/program data. And if I go to look at that, I can see, I go to PC, look at C, and there is no program data. Why? Because it's a hidden folder. I have to do show hidden items, and there's program data. And I could just follow it down Anaconda 3, share, Jupyter, kernels, Python 3. And this is where the Python 3 kernel is. I can go ahead and open this with, say, Notepad. Just once. It pops up here. It says debugger is false. I change it to true. And now the wheels fall off because I cannot save that file. Why? Because the directory itself is actually show my properties. The directory is read-only. And you have to make it writable in order to change anything inside it. If you've got your own version of it installed, you can turn that on, but we can't put on these things. Who cares? No one cares. Anyhow, so quick share of my screen here. If I share the screen off my laptop, it won't do it. Okay, never mind. Find it. Anyhow, but I can turn on that debugger, and I can start putting breakpoints in my code and oh, never mind. Okay, whatever. Anyhow, so I can turn on the debugger, and then I can start find more efficient ways to figure out when there are bugs in my code. So I encourage you to turn that on. Why? Not that you're going to do anything in this course that's complicated enough to require the debugger, but as you get in, try to do professional software development, something like that, you'll find that debugger is a very powerful tool, and it's useful to have that in your arsenal of weapons to use to debug your code. So for instance, how many people in here have ever used a debugger? See, a couple. Yeah, not very many. It's not very popular. If you're doing, simple web programming, things like that, debuggers just are not commonly used. So, but I encourage you to give it a shot, install it, or turn it on, try it out, see what you think.